Hi everyone. Good afternoon, guys. Very good afternoon, everyone. How are you all? Hope you're all doing well. So, because I was not feeling well since last 2 days, I was not taking any classes. Okay, so we'll be continuing these classes. Don't worry. So that SOM Quick Revision, right? What is that we are discussing? You can say that a SOM Quick Revision series will be continuing, right? So up to which one we have seen in the previous class, you can say that stresses on this oblique plane, right? Up to this stresses on this oblique plane we have seen or not, right? If you remember, one sec. Up to stresses on this oblique plane we have seen, you can say here will it happen like that? One sec, just a minute. Right. So up to which one we have seen, right? That stresses on this oblique plane we have seen up to in the previous class, or not everyone, right? So all of you, welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. So what is that referral code you have to use? RP Civil is the referral code you have to use whenever you are subscribing to any plus courses or iconic courses, right? So this is my profile. You can follow me at which, right? And this is the referral code you have to use, right? If you are following my profile already, you can share my profile with your friends, juniors and everybody. Still, if you are not following my profile, you start following my profile now onwards. Okay, here. So these are all GATE 2024 toppers, those who are secured AAR1 from Unacademy, right? Yeah, Pavan, good afternoon. I think you only messaged, right? Now, so this today will be the last date for this offer, all of you. This 50% off on all the gate subscriptions, that is Unbox 2024 offer. Prices are going to be increased soon, so don't miss this. 50% off plus this 6 months extension on this gate subscription, and this will be ending today only, right? So use the referral code RP Civil whenever you are subscribing to this plus and iconic courses. Okay, so plus subscription for 6 months you will be getting at 8,499. Plus subscription for this 12 months you will be getting at which one? This 11,999. So don't miss this opportunity. And here from August 31st onwards, that structural analysis by Abhishek sir will be starting at 9 p.m. and what is it you can say? I will be starting this steel, right? Steel by RP sir. Okay, at 11:45 a.m. So I'll be starting this plus course steel structures. I'll be starting, you can say, right? Don't miss this, all of you. So RP Civil is the code you have to use. So same for 2026 aspirants also, right? This batch will be starting on which one? This is 31st, you can say. And what is it? I will be starting. Abhishek sir will be starting structural analysis, and myself will be starting which one? You can say that is steel structures, right? Myself will be starting that steel structures at which time I will be starting? 11:45 a.m. Yeah, if you are a plus subscriber, you can listen to that. Right. Okay. So these are all when you are taking iconic subscription. So you can take which one? When you, if you are if you are taking an iconic subscription, these are all the books delivered to your home within 15 days of your subscription in the printed format. Okay. So now these are all done, right? So here if you just look at 6 lectures we have done, thermal stresses on this oblique plane we have done, right? Strain energy also we have done, is na? Stresses on this oblique plane we have seen, right? So that sigma theta and this tau theta expressions, right? 55 point gets over now. So this is your lecture 7 quick revision, principal stresses, and this is strains, right? It is not strains, it is strains, you can say. Now we'll be going for this 56th one. First of all, What is that principal plane? Tell me. What is that principal plane if you just observe? What is that principal plane you can say? What is that principal plane everyone if you just observe? The principal plane is nothing but your plane with what conditions? Tell me. So on an inclined plane you may be having which one? These are normal stresses as well as this is shear stresses, na? Is that no? So it is a plane with only normal stresses. Plane with what conditions? Tell me. Only with normal stresses without any shear stresses, right? Without any which one? This is shear stresses. Only normal stresses, right? Without any shear stresses. That is your principal plane, right? So and the stresses on this principal plane are called as which one? That is your normal stresses on the principal plane are called as which one? Tell me. Principal stresses only, no? The normal stresses. The normal stresses present on the principal planes are called as what? The normal stresses on the principal planes are called as which one you can say? Principal stresses. Okay, that is what you are having. Now, if you are writing the expression for this principal stresses, right? What is the expression for this principal stress you can say? Right, Akanksha, good afternoon. What is the expression for this principal stresses you can say? So major principal stress rate, what is the symbol we are giving? Sigma 1. And this minor principal stress rate, what is the symbol we are giving? Sigma 2, na? Major and this minor principal stresses, right? So what is the expression we'll be having if you just observe? That is your sigma 1 comma 2 if you just observe. So how can you get this? Sigma x plus this sigma y by 2 is not? Sigma x plus this sigma y by 2 plus or minus what is that you can say? Under a root. I am not going for the derivation, just the expressions are only important for us, is not? Sigma x plus this sigma y by 2 plus or minus what is it you can say? Sigma x minus this sigma y by 2 whole square plus what is that? Tau xy square, right? This is for this plane stress condition, na? So what is that plane stress condition? You will be having the two normal stresses sigma x and this sigma x, sorry, sigma x, sigma y. These are the two normal stresses you will be having, na? Along with that, right, what are the two sets of this shear stresses will be having? These are your tau xy and this tau x, na? Yes or no? Tau xy is equal to the tau x, you know, right? Now plus whenever you are taking, right, it will be resulting in which one? That is sigma 1 major principal stress will be getting, na? Minus if you are substituting at this plus or minus, you will be getting this minor principal stress sigma 2 you are getting, right? Isn't it? Now if you just consider it, what is there you can say? Position of this principal planes. What is that position of this principal planes? Tell me. Position of this principal planes, right? Yes, tan 2 theta or 2 alpha you can take it, right? So that is which one? That is your tau xy divided by which one? This is sigma x minus this is sigma y by 2, okay? And so what is that? Alpha 1 you will be getting from here. So what is that alpha 2 you are getting? Alpha 1 plus this 19. If you are getting one alpha, right, what is that alpha 2 you are getting, right? Both the planes are perpendicular to each other, definitely or not, right? Both the planes will be, principal planes will be perpendicular to each other, you can say here from this expression. You can understand that, right? Isn't it? Is not clear? No. So shall I go for the next? Noted this one. Everyone noted this or not? Okay. 15th one. So what is it? 15th one, you can say here, maximum shear stress. So what is that maximum shear stress? You consider that is your tau maximum, na? Is no? Maximum shear stress is nothing but your tau maximum or not, right? A tau maximum, you can say. So how can you get this maximum shear stress, that a tau maximum, you can say? Here it is a plus or minus, right? What is that a plus or minus representing? No, yaar. Suddenly it has started, right? Cold, cough and high fever, and rotating. My eyes are rotating fully like that. So still the cold is there, fever has got reduced, cold cough is there still, and but these eyes are rotating now also. Okay, because how many times I can postpone the classes? I cannot postpone every time, no? So that's why I'm taking this class. Yeah, Shruti, good afternoon. So here what is that? You are having sigma x minus this is sigma y by 2 whole square. What is it? You can say plus that tau x y square, na? Isn't? And you can also write this tau maximum is equal to plus or minus, how can you write that? Sigma 1 minus this is sigma 2 by 2, na? Yeah, thank you. Everyone had your lunch or not? All of you had your lunch or not? Your lunch gets over or not, all of you? So sigma 1 minus this is sigma 2 by 2. Okay, sigma 1 minus this is sigma 2 by 2. Maximum shear stress, if you just observe, right? Now tell me what is that plane of this maximum shear after class? Now only having. Okay, very good. What are these planes of this maximum shear, you can say? Planes of this maximum shear stress, right? If you are just observing that tan 2 alpha or 2 theta, you can use anything, right? What is it? You can say exactly in the reverse manner, na? Sigma x minus this is sigma y by 2. Sigma x minus this sigma y by 2 divided by this tau xy, na? So no, divided by this tau xy or not, right? Divided by this tau xy, right? So alpha 1 you will be getting one value, and alpha 2 will be which one? This alpha 1 plus this 90 degrees. Okay, from here. Now tell me what is that on a plane of this principal stresses, on the principal planes, right? What is that shear stress? Tell me. Without any shear stress means, right, on the plane of this. Okay, I'm writing this here. On a plane of principal stresses, so on the same plane where the principal stresses are present, tell me on the plane of this principal stresses, right, what is the shear stress? 0, na? The tau theta. Now similarly on the plane of this maximum shear stress, on the plane of this maximum shear stress, tell me, is that a normal stress becomes a 0 or normal stress is not 0, you can say? Normal stress is 0 or normal stress is not 0? Normal stress is not 0, no? So normal stress on the plane of this it may be 0, it may not be 0, right? What is the, you can say, if you just observe, that is nothing but your sigma 1 plus this is sigma 2 by 2. Okay, that is sigma n dash, right? Or you can also write it as this is sigma x plus this is sigma y by 2, right? You can write both are same only, right? Is that clear now? Principal stresses, principal strains, maximum shear stress, location of the principal planes, and this location of this maximum shear plane. Okay, is that clear, everyone? Once clear, note down. Once not, tell me. We'll move on to the strains part then. Yeah, Satish, good afternoon. Done everyone? Now here analogy. What is the meaning of this analogy? Analogy between this stresses and strains, if you just observe. What is that analogy between this stresses and this strains? Whenever that sigma x, normal stress on the normal stress in the x direction is there, we can have this epsilon x, right? Normal strain in the x direction. Sigma y, normal stress in the y direction, means that is your epsilon y, normal strain in the y direction. Now what is that you can say, if you just observe that tau xy, what is that you can say? Shear stress corresponding to xy plane, right? What is that we can write it? That gamma xy by 2 we have to write it, right? We have to replace the tau xy with gamma xy by 2, right? Why it is like that I will not explain here, right? Because we just have to remember this, right? By 2 will come, na? So no. Or you can also write it as which one? This is 5xy by 2. Okay. Now, what is that? Sigma theta you are replacing with which one? This is epsilon theta. The tau theta we are replacing with which one? This is gamma theta by 2. Okay. Or this is 5 theta by 2. Next, sigma 1 comma sigma 2 major principal stress, minor principal stress can be replaced by which one? This epsilon 1 and this epsilon 2. Okay. That is your tau maximum. It can be replaced by which one? This gamma maximum by this 2. Or we can also write it as which one? This phi maximum by 2. Yes, no? Like that we have to replace now. Whenever there is a stress term, you have to replace with the corresponding strain term. No? No? Whenever there is a stress term, right, you have to replace it with the corresponding strain term or not? Isn't it? So shall we move on to this next? I let the expression for this strains on this inclined plane and this principal strains expressions. Shall we go for? Okay, I'll just go for this, right? What is it you can say? Strains on the inclined plane. Here again it started rotating my eyes. One sec. Strains on this inclined plane, if you just observe, this is your epsilon x, that is your epsilon y, and what are these strains you can say? That is your gamma xy by 2 will come into picture. This is your gamma xy, okay, xy only, but by 2 will come later. Okay, the formula only, that by 2 will come into picture. Now strains on this inclined or this oblique planes. So this oblique plane is inclined at an angle theta with respect to this, right? What is it you are having? You can say this is your epsilon theta. What is this one? This is your gamma theta, isn't it? Yes, na? So normal strain and this is shear strain you are having, na? Now tell me that epsilon theta, how can you get that? Sigma x plus sigma y by 2, na? So therefore we can write it as epsilon x plus this epsilon y by 2 plus sigma x minus sigma y by 2 into that cos 2 theta, na? So here we will be writing epsilon x minus this epsilon y by 2 into that cos 2 theta plus tau xy sin 2 theta, na? In place of this tau xy we can write it as which one? This gamma xy by 2 will come into picture, na? Into that sin 2 theta. Okay, there tau theta, na? Here gamma theta by 2, right? We have to replace the tau theta with gamma theta by 2, right? So this first term will not be there, but cos 2 theta will become sin 2 theta, sin 2 theta will become cos 2 theta, and this plus sign will become this minus sign. Epsilon x minus this epsilon y by 2 into that cos 2 theta will become which one? Sin 2 theta, na? Minus what is that you can say? Gamma xy by 2 into that which one? This cos 2 theta. Is, na? Is that clear now? that is strains on this oblique plane if you just consider. Is now what is that you can say if you just observe? Now what is that you can say if you just say principal strains major and this minor principal strains, right? What is the major and this minor principal strains? Epsilon 1 or this epsilon 2 is equal to, right? What is it you can say? Sigma x plus sigma y by 2, that can be replaced by this is epsilon x plus this epsilon y by 2, plus or minus, right? What is it you can say? Sigma x minus this sigma y by 2. Now here we can write it as epsilon x minus this epsilon y by 2 whole square, plus what is that you can say? Tau xy square. Now this tau xy square we can write it as which one? This is gamma xy or gamma xy by 2 square. Gamma xy by 2 whole square will come into picture. Whenever you are taking this plus major principal strain, whenever you are taking this minus minor principal strain, epsilon 2 will come into picture. The last point for today, what is that maximum principal strain you can say? Tell me. Sorry, maximum shear strain. One sec. Yeah, under root term. Here what is that you are having? Tau xy. Sigma x we are replacing with epsilon x. Sigma y you are replacing with epsilon y. Tau xy we are replacing with the gamma xy by 2 simply. Okay. Yes, this under root term only will come. Maximum shear strain. Yeah, radius of this Mohr circuit. Okay. That gamma xy by 2 equal to plus or minus, right? How much you can say? Under root epsilon x minus this epsilon y by 2 whole square plus this gamma xy by 2 whole square. Yes, now if you simplify this, right, in the similar format if you are writing, so what is that sorry, gamma max by 2 we have to write it, not the gamma xy by 2. This is gamma max by 2 that is your gamma maximum by 2. Yes, so now that gamma maximum by 2, how can you get that? You can say that is epsilon 1 minus this epsilon 2 by 2 this 2 will get cancelled, isn't it? So like that we'll be having. Okay, this is how we'll be getting the expression for this principal stresses, principal strains, and all these things, is not? So mostly today will be the last class on YouTube. So next September onwards, right, my YouTube classes will not be there. Only special classes I'll be taking. Okay, for free classes, special classes only I'll be taking. Okay, this SOM Quick Revision also I'll be here. That tau maximum, do you remember? The tau maximum will be sigma 1 minus this sigma 2 by 2 in place of this tau maximum, what is that we can write it? Gamma maximum by 2. You mentioned already. Tau maximum in place tau maximum, we have to write this gamma maximum by 2 equal to, in place of sigma 1 epsilon 1, in place of sigma 2 epsilon 2 divided by this 2. This 2 gets cancelled. Gamma maximum is equal to sigma 1 epsilon 1 minus this epsilon 2. Got it now? Clear? Anyone having any doubts in our discussions till now? Up to this Mohr circle, voila. Anyone having any doubts? Okay. No doubts, I'll close the session. If doubts are there, I'll just discuss those doubts first. Clear? Everything is clear? Yeah, actually that SOM will be going on in the evening until it's get completed. And in the morning, which one? Steel will be starting from 31st. Okay? Yes, Satish, correct. In the evening 8:30 p.m. that SOM will be continued until it's getting completed. Okay? Morning 11:45 a.m. still will be there. Okay. Okay. Thank you. Thank you all of you. Have a good day. Anyone having any other doubts? Any other doubts for anyone else? Okay. Thank you all of you. Have a good day.